Okay, today's lesson is going to be on the sun and the seasons. This lesson is going to teach us about the reason why we experience seasons here on planet Earth. Before we move forward with that, let's once again revisit the difference between rotation and revolution because, like I've said again and again, it's incredibly important for being successful in this unit. Rotation is when an object spins. Okay, we said in the previous lessons that the Earth spins on its axis once every 24 hours, and that's what we call a day. Revolution is when an object travels around or orbits another object. The Earth revolves around the Sun, and it takes the Earth 365 days, or 1 year, to make the entire revolution around the Sun. To make the trip around the Sun one time takes a year. So again, keep these differences in mind, and by this point, really, anytime I say rotation or revolution, you should automatically know which one of these movements I'm talking about without having to think about it for very long at all. Alright, like I just said, the Earth's movement around the Sun is called a revolution. The Earth's revolution and its tilted axis are what cause the changing of the seasons. Now we're going to go more in depth on this, but when you're taking a test or answering an assignment question, oftentimes this is the answer and this is adequate enough. You're not really asked to go in depth about it, just to identify that it's Earth's revolution and its tilted axis that are responsible for the changing of the seasons. So that's the short answer right there. So anytime you see a question somewhere along the lines of what causes us to experience seasons on Earth, or what is the reason we have seasons, the answer is Earth's revolution around the Sun and its tilted axis. Alright, differentiated heating by the Sun. As the Earth moves around the Sun, different parts of the Earth get different amounts of solar radiation. Some parts of the Earth get a more direct angle of sunlight, while others get a more indirect angle of sunlight. The more direct an angle of sunlight is, the warmer that sunlight will be on Earth. You can experience this for yourself in a little experiment. You can take a lamp that puts off a significant amount of heat, and you can aim it at yourself directly and feel how much heat you're feeling from it, and you can aim it at yourself kind of indirectly at an angle and notice that you're not feeling as much heat. And what's really going on here is that the rays, when they're striking you directly, they're more concentrated, and therefore you feel more of the heat. The heat is concentrated in a smaller area. But when light hits at an angle, that energy is spread out over a larger area, so it doesn't feel as warm. The energy is not striking as focused of a point. Okay? And let me go ahead and emphasize, as you go through this lesson, you should definitely check out the videos and the other learning aids that I've put on Google Classroom that relate to this lesson, because they're going to illustrate these concepts way better than I can with just words and this PowerPoint alone. Okay, on the Earth, we have this point where at any given time, sunlight is hitting most directly. Okay, it's not always at the same point, but we always have this one point on the Earth where sunlight is hitting most directly, and we call that the subsolar point. So, as the Earth revolves around the Sun, the subsolar point constantly travels between the tropics. And before we add more to that, let's talk about a little bit about the Earth's geography here. Okay, most of you probably already know this line in the center of the Earth here that wraps around the globe kind of like a belt, we call the equator. This divides the Earth into a northern hemisphere and a southern hemisphere. Okay, about 23 degrees north of the equator, we have this other imaginary line that we refer to as the Tropic of Cancer. And then on the other hand, at roughly 23 degrees south latitude, we have this other imaginary line that we refer to as the Tropic of Capricorn. Okay, so as the Earth travels around the Sun Whoops. The subsolar point does this over the course of the year. You can watch the movement of my mouse pointer here to see what I'm talking about. So, over the course of the year, all right, the subsolar point travels between the tropics, up and down like this. So, in spring, for the northern hemisphere, subsolar point is at the equator, and throughout the spring, it moves northward until on the first day of summer, it's on the Tropic of Cancer. All right, then as the summer progresses and we're moving back towards fall, the subsolar point travels back to the equator. Then, as we go into winter in the northern hemisphere, the subsolar point travels down to the Tropic of Capricorn and arrives here at the Tropic of Capricorn on the first day of winter in the northern hemisphere. And then as we go back to spring, the subsolar point travels back to the equator. Okay? Now, I mentioned this in our last lesson, but I'm going to point this out again. When we have summer here in the northern hemisphere, the southern hemisphere has winter. When we have winter here in the northern hemisphere, the southern hemisphere has summer. Okay? So this is going to be important to remember later as we talk about the changing of the seasons. All right, solstices and equinoxes. Each year the Earth experiences 2 solstices and 2 equinoxes. A solstice occurs when the subsolar point is on one of the tropics. Okay, like I was saying. In the northern hemisphere, solstice will occur for summer and winter, and same with the southern hemisphere, but they happen at opposite times. An equinox occurs when the subsolar point is on the equator, which happens anytime we have spring or fall. Okay? So each hemisphere, north and south, is going to have its own vernal equinox, which is a fancy way of saying spring equinox, summer solstice, autumnal equinox or fall equinox, and winter solstice. And we're going to go through each one of these individually. And you're going to start to see a pattern. And the pattern is a pattern of opposites between the northern hemisphere and the southern hemisphere. And it's just like I've been explaining. If the northern hemisphere is in summer, then the southern hemisphere is in winter. If the northern hemisphere is in winter, the southern hemisphere is in summer, and so on and so forth. All right, the vernal equinox. The vernal equinox is also known as the spring equinox. In the northern hemisphere where we live, it occurs around March 21st each year. Sometimes it might be a day or two earlier or a day or two later, but it's always right around March 21st each year. In the southern hemisphere, the vernal equinox occurs around September 23rd each year. At the equinoxes, the length of day and night is an almost equal 12 hours each. Okay? Hence the name equinox, which means equal night. Okay? Basically, the name explains that the time period of day and night is almost equal. Okay? 12 hours of daylight, 12 hours of nighttime. All right, during both hemispheres' vernal equinox, the subsolar point is on the equator. So anytime there's an equinox, the subsolar point is on the equator, and that's easy to remember. Equator, equinox, works out nicely. All right, so just to be kind of thorough, I'm going to go ahead and say when the northern hemisphere has its spring equinox, at more or less the same time, the southern hemisphere has its fall equinox or its autumnal equinox. Okay, and then vice versa. When we're having the fall equinox here in the northern hemisphere, the southern hemisphere is having its spring equinox. All right, autumnal or fall equinox. All right, the autumnal equinox is sometimes also referred to as the fall equinox. Here in the northern hemisphere, it occurs around September 23rd each year. Again, it might be a day or two before or a day or two after the 23rd, but usually it's right around September 23rd. In the southern hemisphere, the autumnal equinox is going to occur right around March 21st. Okay, you're starting to see this pattern again I've been explaining over and over again. Okay. All right, at the equinoxes, again, the length of day and night is an almost equal 12 hours each. And during both hemispheres' autumnal equinox, just like the vernal equinoxes, the subsolar point is on the equator. Okay? And again, just to be thorough, when we're having the autumnal equinox here in the northern hemisphere, at that very same time, the southern hemisphere will have its vernal or spring equinox. Okay? So just remember, whatever season it is here in the northern hemisphere, it's the opposite season in the southern hemisphere. Okay, the summer solstice. All right, in the northern hemisphere, the summer solstice occurs around June 21st each year. Again, maybe a day or two earlier or a day or two late, but always somewhere around June 21st. In the southern hemisphere, it occurs around December 22nd each year. At the summer solstices, the length of the day is at its longest. You've probably noticed this during summertime. That during summer, the days are a lot longer than they are during winter. During the northern hemisphere's summer solstice, the subsolar point is on the Tropic of Cancer. That is the tropic in the northern hemisphere. Okay, so the Tropic of Cancer in the northern hemisphere is getting the most direct sun rays that the Earth is getting, and therefore the northern hemisphere has summertime and summer weather conditions, or seasonal conditions, we should say. All right, during the southern hemisphere's summer solstice, the subsolar point is on the Tropic of Capricorn, which is the tropic of the southern hemisphere. So the most direct sun rays at that time are hitting in the southern hemisphere and causing the southern hemisphere to have those summer seasonal conditions. All right, again, just to be thorough, when we're having summer solstice here in our northern hemisphere, the southern hemisphere is going to be having its winter solstice. Okay, we're about to talk about that one. All right, winter solstice. In the northern hemisphere, the winter solstice occurs around December 22nd each year, so close to Christmas time. Maybe a few days before December 22nd, maybe a few days after, but always somewhere around December 22nd. In the southern hemisphere, it occurs around June 21st each year. So, here in the northern hemisphere, when we think about winter, and especially Christmas time, which is right around the winter solstice, we think about those traditional kind of Christmassy scenes we see on postcards and all over the internet and in stores is snow and those kind of things, and we associate the winter and Christmas time with cold weather, of course, but in the southern hemisphere, I mean, they celebrate Christmas at the same time, but it's during their summer, so they don't really equate Christmas time with cold weather the way we do in the northern hemisphere. So again, keep that in mind. When we're having winter here in the northern hemisphere, they're having summer down there in the southern hemisphere, even though the dates are the same. So they have winter in June down there. All right, at the winter solstices, the length of day is at its shortest. You've probably noticed this. By 5:30 p.m. at the winter solstice, it's pretty much dark outside. All right, we have longer night times than we do daytimes during the winter solstices. All right, during the northern hemisphere's winter solstice, the subsolar point is on the Tropic of Capricorn. Okay, so that's the tropic down there in the southern hemisphere. Okay, so when we're having our winter solstice here in the northern hemisphere, the subsolar point is as far away from us as it's going to get. It's down there on the Tropic of Capricorn in the southern hemisphere. All right, when the southern hemisphere has its winter solstice, the subsolar point is on the Tropic of Cancer, which is the northern hemisphere's tropic. Okay? So again, we've got this, I like to call it the game of opposites, because when you're remembering, when you're trying to notice and remember which season is which, you kind of have to play this game of opposites to remember. Okay? If the northern hemisphere is having winter, of course the southern hemisphere is having summer. Okay, so this slide asks, why do we have seasons? That's been the big question of our lesson. We experience seasons because the Earth rotates on an axis that's tilted in its orbit, and also the Earth is revolving around the sun. Okay? The axis is tilted at 23.5 degrees, and that causes different hemispheres to be at different angles to the sun at different times of the year, okay? Just like we've been saying. And you can look at this picture here, and you can see it shows you different times of the year, and it shows you which hemisphere is tilted towards the sun or which one's tilted away from the sun, okay? And you can look here in the pictures, and you can see this is talking about the northern hemisphere, since we live in the northern hemisphere. And you can see here, December 22nd, you can see the northern hemisphere is facing away from the sun. Okay, it's facing this way, so it's getting less direct sunlight, and therefore it is colder. We're experiencing winter-like conditions. Okay, on the other hand, 6 months later, June 21st, the summer solstice, you can see that the northern hemisphere is angled towards the sun. Okay, and therefore it's getting more direct sun rays and getting more solar energy and experiencing summer-like conditions. And then in between you have fall, where neither hemisphere is tilted toward or away. It's pretty much equal. And the same thing in spring. See, northern hemisphere and the southern hemisphere, it's pretty equal, that neither one is really tilted away or towards. Right, the subsolar point is right on the equator, both in spring and in fall. Okay, notice that the axis does not rock back and forth. If you look in every picture, the axis is pointing in the same direction. Okay, it's just that when the Earth revolves around the sun, it makes that axis, which way it's pointing, the North Pole there, it just makes it where it's pointing either towards or away from the sun. You can see how it's pointing towards the sun here. Really neither here or neither here, but pointing away from the sun here. Okay, so that's what's causing that difference in which hemisphere is tilted toward or away from the sun. Okay, the Earth is not rocking back and forth. It's staying tilted at 23.5 degrees on average. It's just that as the Earth moves around the sun, all right, it causes one or the other hemispheres to be tilted toward or away the sun, just because of the side of the sun it happens to be on. You must check out the videos and animations that go along with this lesson to really get a good visual of how this works. Okay, you're not going to get it just from looking at this picture. This is a great graphic, but really, to get the best image in your head, you need to look at those animations and those videos. So please do. Alright, so I was saying earlier that over the course of a year, the direction of Earth's axis does not change, okay? And for the most part, that's true. It changes ever so slightly, but the amount over the course of a year is so slight, it's negligible, meaning it just doesn't even really warrant consideration. Now, on the other hand, over a long period of time, 26,000 years, all right, the tilt of Earth's axis, the direction of it does change. It makes a complete cycle all the way around. Okay, and we call this precession. This is pretty hard to see in your head or imagine, and the best thing to do is to look at the visual aids that I've included. It's often very hard to find visual aids that are good on this, videos and visual aids on precession. It's just not talked about that much outside of academia. All right, so in this cycle, Earth kind of wobbles. All right, the angle of the axis is not affected. It still stays at 23.5 degrees on average. All right, but the direction in which it points changes over that time. All right, this wobble, known as precession, happens because of the gravitational pull from the moon. It causes this wobble. All right, the circle that's traced out by the axis, this imaginary circle that's traced out, we call the precessional axis. Okay. All right, if you look at the picture at the top here, all right, that's kind of a sped up version of what the Earth actually does, its axis does. But just consider this like a time-lapse video, because each time that precessional wobble occurs, 26,000 years have passed. So if you say that the starting point is now, there you've seen 26,000 years elapse, and then again, then another 26,000 years, then another 26,000 years. Okay, so it takes a very long time for this wobble to occur. All right, so What is significant about precession? All right, roughly 12,000 years from now, which is halfway through this precessional cycle, it'll make the time that the seasons occur for each hemisphere change. Okay, so 12,000 years from now, if human beings are still lucky enough to be alive, our ancestors or our descendants here in the northern hemisphere, they will experience summertime in December and wintertime in June. Okay. On the other hand, the descendants of people in the southern hemisphere, they'll experience the kind of time of the seasons that we currently do. Okay, they'll have winter in December and summer in June. Okay, and then after another 12,000 years, when this 26,000 year or so cycle is completed, everything will be back to the way it is now. Okay, so excuse me. If asked on an assignment or a test what the significance of precession is, it's this: it causes the seasons to happen at different times of year of the year for the different hemispheres. And there's one other significance that we need to know, and that is that precession also causes Earth's North Star to change. Okay, the North Star is the star that the North Pole points at. Okay, as the precessional cycle goes on, then the North Star changes. Okay, and you can see that here in the drawing. Okay, all right. So currently, our North Star is this star called Polaris. All right, about 12,000 years from now, 14,000 AD, Vega will be our North Star. Okay, and then also they've included Thuban here. That was our North Star about 5,000 years ago. Okay, and there will be other North Stars along the way as the precessional cycle happens, but they're just showing you the two extremes, Polaris and Vega. Okay, and here's the thing, 13 or 14,000 years ago in the past, Vega was once our North Star. Okay, so this happens over and over again. Right now we're currently at Polaris, but about 12,000 years from now, the North Star will be Vega, and then, certain amount of years, Thuban again, and like I say, all the other ones along the way. Okay, so this is the other thing that's significant about precession. If you're asked on a assignment or test, it changes Earth's North Star. Okay, it causes the axis, Earth's North Pole, to be pointed at a different star over time, or at different stars over time, I should say. All right, we have one more wobble in Earth's axis that we need to talk about, and this one is known as nutation. Okay, nutation is a change in the tilt of Earth's axis by half a degree one way or the other. All right, this causes the tilt to move back and forth from 23 degrees and 24 degrees. Okay, so again, if you're asked on an assignment or a test to what degree is Earth's axis tilted, the answer is going to be 23.5. Okay, always answer 23.5 degrees. However, that is actually an average, because due to nutation, the tilt actually moves back and forth between 23 and 24 degrees, and this occurs over an 18-year period. This also is due to gravitational forces of the moon, but also due to gravitational forces of the sun and the other planets. And the significance of nutation is that it causes seasons to be either more or less extreme. Okay? For instance, when the degree of the tilt is greater, when it's closer to 24 degrees, we're going to experience slightly warmer summers and slightly cooler winters. Okay? When the tilt is less extreme at 23 degrees, we'll have slightly less extreme summers and winters. Okay? So just keep that in mind. It causes seasons to be more or less extreme. By more extreme, we mean colder winters, hotter summers. By less extreme, we mean not quite as hot summers and not quite as cold winters. And here we have a little diagram of the nutational movement. Okay, that back and forth movement of the tilt of Earth's axis. And here's another diagram illustrating this movement. And again, this is one that's easier to observe because it only takes 18 years for this cycle to happen.